2D arrays again. Before we finish with searching and sorting, let's look at how we might search a 2D array. Let's say we have this 4x6 2D array. If we wanted to know if this nums contains the value 7, how could we go about that? The easiest strategy would be to search the 2D array row by row, where each row is a regular 1D array. So first, we will search this row. Then, we will search this row. Then, this row, and so on. If at any point we find the number we're searching for, like this 7 here, we stop searching and return true to indicate the value exists in the array. Let's code it. First, let's write the skeleton of our search method. For parameters, it will need to pass the 2D array, of type int in this case, that will be searched, plus a parameter for the item we are searching for. The method will return a Boolean value to indicate whether the item was found or not. The first thing we want to do is iterate over the outer array, meaning we want a loop to go through each row, or 1D array. We'll use our enhanced for each syntax. For int array row in nums. Recall that when we iterate over a 2D array, the type in the outer loop is itself an array. Thus we declare our variable as integer array row. Now we iterate over the inner array using our row variable. This will search each element of type int in the row. Our next to last step is to return true if we find a match. So if value equals n, return true. Why next to last? What else is there? What if the search term is not found? We still have to return false. If we get through all the values of all the rows and haven't found it, it's not there. So at the very bottom, we have return false. Let's try one more thing. Without changing the code, let's break this up into two separate, simpler, but overloaded methods. First, let's write a method to search through the row elements or each 1D array. We will pull this from the inner loop we wrote. Notice anything familiar? We have already written this method earlier in the unit. It was slightly different and looked like this. Only the variable names are different. Since we already have this method, let's use it because it doesn't matter what the variable names are. Now we can replace the inner loop of our 2D search with a call to the 1D version of the method. So if contains row n, return true. So which is better, the version that does the whole search in one method or the one that breaks it into two methods? Ultimately, it's your choice, but the two-method version has a couple of advantages. Number one, two simpler methods instead of one more complex method can be easier to debug, read, and maintain. 2. If you also need to search 1D arrays, you have a method that does just that.